Good afternoon. I'm Remi Seguy. I work at the European Commission, and I'm going to give an update on OpenTIDE, our management framework we have been developing since 2022. The core concept is to take all the threat intelligence we receive to turn it into a structured threat vectors, a set of threat vectors, and to use them to drive how we are going to cover them with our detections, and to do that as code. So the framework, on the left, you have all the unstructured threat intelligence, PDF files, blog posts, etc., sometimes also a bit structured. Then we have models to document the attack vectors, we call threat vectors. And then once we have documented that, we are going to define what detection objective we need to cover those threats. And we are going to develop the detection rules, implementing the detection objectives. And the detection rules are automatically deployed on the different detection platforms we support via the API. We follow all the DevSecOps principles. We call that detection ops. With the threat vectors, you can chain them to express attack path. So on the left, you have the YAML file where you define how that threat vector relates to the other threat vectors. And in the documentation, you will see the graph. Here it's a view of the knowledge graph we have with all those objects in the framework. You can also map to attack navigator, and this helps to prioritize your detection coverage. For instance, here the purple means you have documented a threat vector relevant for your organization, but you don't have detection yet in place. To support you in drafting the YAML files, because everything is a YAML file, there is a lot of inline validation. There is a schema. So a lot of vocabularies, etc., are already available. You can do full text search even on the MITRE ATT&CK matrix. Here is an example for the detection rules where we have the detection rule, the top with the metadata, and we have subsections to define not only the query, but all the parameters to deploy the detection on the platforms. On the left, for the same detection rule, you have the KQL, Sentinel part. On the right, the Splunk part. The documentation is automatically generated when you commit, you merge one object. Automatically, there is a pipeline job to create the documentation and to also include snippets of the knowledge graph. You can use OpenTIDE for different use cases to manage your threat vectors together with the detection objectives, or to manage the rules only. But the best use case is to take the whole and to manage end-to-end from the threat vectors down to the rules, your system. So now the project, which is on GitHub, is organized this way. If you want to start, you will have to copy init.tide, which is the initial structure for your instance of OpenTIDE that you can host on your private Git. Then each time you are going to push content to your instance, there will be a pool from CoreTIDE, and you can also use a local clone of CoreTIDE. If you want to see what we have shared as threat vectors for the moment, and we are going to release a set of detection objectives with TLP clear, you can have a look on ShareTIDE. This is the collection of YAML files for the threat vectors we have released. And for convenience, you can see on WikiTIDE the equivalent of the threat vector for the documentation. this is another way how to proceed. You prepare your repo, you copy init.tide, you have some configuration to do to put the secrets to connect to your detection platform, etc. And then you are ready to start creating issues, merge requests, and publishing content on the repo. So with OpenTIDE, you do detection engineering, detection ops, and you do detection as code. And those are the point of contact. So check out, and please provide feedback. Don't hesitate to open pull requests on GitHub. Thank you.